The Curiosity rover just captured something from the surface of Mars that has NASA scientists scrambling to explain what they're seeing. After years of photographing rocks and dust, Curiosity turned its high-resolution cameras skyward and captured the clearest, most detailed image of 3I/ATLAS ever taken. And what that image reveals is keeping researchers awake at night. This isn't some blurry dot in the distance. This is a crystal-clear photograph showing details that telescopes orbiting Earth couldn't capture. Structure, geometry, features that look disturbingly artificial. And here's the shocking part. Atlas is close enough to Mars that Curiosity's cameras can see things that shouldn't be visible on a natural space object. The image shows what appears to be distinct sections on ATLAS's surface, areas with different textures, colors, and reflectivity. There are straight edges where natural objects should have irregular curves. There are patterns that repeat with geometric precision. And most unsettling of all, there are features that look suspiciously like ports, panels, or openings of some kind. NASA released the image to the scientific community, but haven't made any official statement about what those features might be. Radio silence from the agency that usually can't wait to share Mars discoveries. When they go quiet about something this significant, it means they're either not sure what they're looking at, or they know exactly what it is and aren't ready to tell us. The thing nobody tells you is that Curiosity wasn't supposed to photograph ATLAS at all. The rover's mission is to study Mars geology and search for signs of ancient microbial life. Pointing cameras at passing space objects isn't part of the standard protocol. Someone at Mission Control specifically commanded Curiosity to stop what it was doing and capture this image. That kind of directive comes from very high up the chain of command. Before we break down what this image reveals, smash that like button and subscribe, because what we're about to show you is going to change how you see this entire mystery. Let's talk about what makes this image so extraordinary and why it's creating such controversy in the scientific community. Curiosity's Mastcam Z camera system is one of the most sophisticated imaging instruments ever sent to another planet. It can capture images with resolution fine enough to see features smaller than a millimeter from several meters away. When pointed at Atlas in the Martian sky, it produced an image that's roughly 50 times more detailed than anything the Hubble Space Telescope or James Webb have captured of the object. Why? Because Curiosity is millions of miles closer to ATLAS than Earth-based or Earth-orbiting telescopes. It's like the difference between photographing someone from across a football field versus standing right next to them. Details that were impossible to see from Earth suddenly become crystal clear from the Martian surface. The image shows Atlas as an elongated object, roughly cigar-shaped or cylindrical, spanning approximately 800 meters in length and 200 meters in diameter. But it's not the size that has scientists in heated debates, it's the surface features. An imaging specialist who analyzed the photograph described what stands out immediately. Natural space objects, asteroids, comets, space rocks, have surfaces that are chaotic and irregular. Impact craters, random boulders, uneven terrain. This object has sections that are smooth, deliberately smooth, and there are boundaries between different surface types that are too sharp, too straight to be natural erosion or geological processes. The image shows at least 7 distinct surface zones, each with different properties. One section appears metallic and highly reflective, bouncing sunlight in ways that suggest polished metal rather than ice or rock. Another section is darker, absorbing light almost completely, like stealth coating on military aircraft. A third section shows what looks like a honeycomb pattern of hexagonal shapes repeated across hundreds of square meters. Hexagons appear in nature, beehives and crystal structures, for example, but they appear at microscopic or small scales. The hexagons visible on Atlas are massive. Each one appears to be 15 to 20 meters across. That kind of large-scale geometric patterning doesn't occur naturally in space objects. But here's what really has researchers arguing. Near what appears to be the object's midpoint, there's a feature that looks disturbingly like an opening. Not a crater from impact. Not a random depression. a rectangular opening with straight edges and sharp corners, approximately 50 meters wide and 30 meters tall. Natural geological processes don't create rectangular holes. A planetary geologist who reviewed the image put it bluntly, "If I saw this feature on Mars itself, I'd call it a cave entrance or a mine shaft." But this is on an object traveling through space. Caves don't exist on comets, which means either we're seeing something we don't understand about how these objects form, or we're looking at something that was constructed. The timing and circumstances of this photograph add another layer to the mystery. Curiosity didn't just randomly happen to capture Atlas. The rover was deliberately positioned and commanded to take this specific image at this specific time. And that raises important questions about what NASA knew before the photo was taken. Curiosity is currently exploring the Geddes-Vallis Channel in Mount Sharp's foothills, a location chosen for its geological significance. The rover's cameras are typically pointed at the ground or at nearby rock formations. To photograph Atlas, mission controllers had to halt normal operations, calculate the exact time Atlas would pass through Curiosity's field of view, and position the rover to point its cameras skyward at a precise angle. That kind of planning takes days, which means NASA knew several days in advance that this imaging opportunity would produce something worth seeing. They didn't just get lucky, they orchestrated this photograph deliberately because they wanted high-resolution confirmation of something they suspected from earlier, lower-quality observations. A former NASA mission planner explained the significance. Rover time on Mars is precious. Every minute of operation is planned months in advance. To interrupt that schedule for an unplanned photography session means someone very high in the organization decided this was more important than the rover's primary mission. That decision doesn't get made lightly. The timing is also significant. Atlas was at its closest approach to Mars, approximately 4 million miles away, when Curiosity captured the image. At that distance, the object appears roughly the same angular size as Earth's moon appears from the surface of our planet. It's close enough for detailed photography, but far enough that it's not threatening Mars directly. But here's what's interesting. This is the exact viewing geometry that would show ATLAS in optimal lighting conditions. The sun was behind Curiosity, illuminating ATLAS's face directly. No shadows, no glare, perfect conditions for revealing surface details. That's not coincidence. Mission planners waited for the perfect moment to capture this image, suggesting they knew exactly what features they wanted to document. The rover's position in the Geddes-Vallis Channel also matters. The rover was on elevated terrain with a clear view of the sky, no mountains or crater walls blocking the horizon. It's almost as if someone positioned Curiosity at that location specifically to have an unobstructed view when ATLAS passed overhead. When you compare Curiosity's image with photographs taken by Mars orbiters and Earth-based telescopes, the differences are stunning, and those differences reveal features that space agencies might prefer the public didn't see so clearly. The Mars Reconnaissance orbiter captured images of Atlas from its position in Martian orbit, roughly 12,000 miles above the surface. Those images showed Atlas as a small bright object with some visible structure but limited detail, useful for tracking but not revealing. Earth-based telescopes, even giants like the Hubble and James Webb, captured images showing Atlas as essentially a fuzzy blob with some elongation, enough to determine it's not spherical but not enough to reveal surface features. But Curiosity's ground-based image, it's like switching from standard definition to 4K ultra-high definition. Features that were invisible or ambiguous in other images suddenly become clear and undeniable. A comparative imaging analyst described what becomes visible. In orbital images, ATLAS looks like an elongated rock with maybe some color variations. In Curiosity's image, you can see distinct surface zones with different materials, geometric patterns, and structural features that suggest component assembly rather than natural formation. One feature in particular becomes much more obvious in Curiosity's image, what appears to be a seam running along part of ATLAS's length. In lower resolution images, This appeared as a faint line that could have been a shadow or color variation. In Curiosity's detailed photograph, it clearly looks like a joint where two sections connect, like panels on a spacecraft hull. The reflectivity patterns also tell a story. Natural space objects reflect sunlight relatively uniformly based on their composition. Ice reflects one way, rock another, metal another. Atlas's surface shows reflectivity variations that don't match any single material type. Some sections reflect like polished metal. Others absorb light like carbon fiber composites. Still others show intermediate properties. A materials scientist analyzing the reflectivity data explained, "What we're seeing is consistent with a surface made of multiple different engineered materials, each optimized for different functions. Thermal control surfaces, structural panels, sensor arrays, these are the kinds of material combinations you'd see on a spacecraft, not a comet." Most controversial of all, when you enhance the contrast and brightness of Curiosity's image, additional details emerge. What appear to be surface markings or symbols, lines that could be panel edges, and small protrusions that might be antennas, sensors, or other equipment extending from the hull. NASA hasn't commented on these enhanced details, which is telling. When images show interesting geological features, NASA typically releases enhanced versions highlighting those features. The fact that they released the raw Curiosity image but haven't provided detailed analysis suggests they're still debating internally what those features represent, or they've decided that detailed analysis would reveal too much. The geometric features visible in Curiosity's image are perhaps the most compelling evidence that ATLAS isn't a natural object. Because when you analyze the mathematics of what's visible, the odds of natural formation become astronomically small. The hexagonal pattern mentioned earlier shows remarkable regularity. When researchers measured the hexagons visible in the image, they found that they're uniform in size to within 2 to 3%. Natural crystal structures can produce hexagonal patterns, but with significant size variations. Perfect uniformity suggests manufacturing or growth under controlled conditions. A mathematician analyzing the pattern described it as troubling. Random natural processes produce random results. Even when patterns appear, like crystals or sand dunes, there's always variation because conditions aren't perfectly uniform. These hexagons show the kind of consistency you only get from controlled manufacturing processes or biological growth following precise genetic instructions. The straight edges and sharp corners visible in several locations also defy natural explanation. When rocks tumble through space, they erode into rounded shapes. Impact craters create circular depressions, not rectangular openings. The features visible on Atlas include angles close to 90 degrees, right angles that appear multiple times across the surface. A geological engineer made the comparison clear. On Earth, when you see right angles in nature, it's almost always from human construction or occasionally from crystal cleavage planes on a small scale. At the scale we're seeing on Atlas, features tens of meters across with sharp 90-degree corners, there's no natural geological process that produces that. The object's overall proportions also raise questions. The length-to-width ratio is approximately 4 to 1, a cylinder 4 times longer than it is wide. While natural objects can be elongated, the specific ratio visible on Atlas happens to match optimal proportions for spacecraft design, long enough to provide structural integrity and space for systems, narrow enough to minimize cross-section for radiation shielding and aerodynamics. Perhaps most intriguing, when researchers applied computational analysis to identify symmetry in the image, they found bilateral symmetry along Atlas's long axis. The left and right sides appear to be mirror images of each other. Natural space objects are chaotic and asymmetric. Designed objects often show symmetry because it simplifies construction and provides balanced structural properties. An aerospace engineer reviewing the analysis noted, "Bilateral symmetry is a hallmark of designed vehicles. Aircraft have it, spacecraft have it. It provides balanced thrust, uniform stress distribution, and simplified construction. Finding it on an interstellar object is like finding a perfectly symmetric stone tool, possible through luck, but far more likely to indicate intelligent design." While NASA released the Curiosity image to the scientific community, they've been notably silent about several specific features that independent researchers have identified. And that silence is deafening. The rectangular opening near ATLAS's midpoint has generated intense speculation. Its dimensions, approximately 50 meters wide by 30 meters tall, are remarkably similar to cargo bay dimensions on large Earth spacecraft. The Space Shuttle's cargo bay was 18 meters long and 4.6 meters in diameter. The opening on ATLAS is proportionally larger, but follows similar aspect ratios. A spacecraft design engineer made an observation that NASA hasn't addressed. If you were designing a large interstellar vessel, you'd need external access ports for maintenance, cargo handling, and possibly deploying smaller craft. The rectangular opening we're seeing is positioned near the object's center of mass, exactly where you'd place a major access point for structural balance. There are also smaller features visible near what might be the object's forward section. Protrusions extending from the surface, regularly spaced in what looks like a deliberate array. These could be antennas, sensors, or communication equipment. Each protrusion appears to be similar in size and shape, again suggesting manufactured uniformity rather than natural formations. Independent analysts using image enhancement software have identified what appear to be surface markings near one of the reflective sections, lines or symbols that could be writing, identification numbers, or navigational markers. The resolution isn't good enough to definitively confirm what these markings represent, but their presence alone is significant. Natural objects don't have surface markings that resemble text or symbols. One linguistic analyst who examined the enhanced images noted, "If those are indeed symbols or writing, we're looking at evidence of technology and possibly communication. Written language is a clear marker of intelligence. Even if we can't read it, the mere presence of systematic markings would be profound." Perhaps most concerning, there appears to be a faint glow visible from the rectangular opening. Not reflected sunlight, this appears to be emission from inside the object. It's extremely faint in the original image, but becomes visible when brightness is enhanced. Something inside Atlas might be generating light, which would require either ongoing chemical reactions or active power systems. A power systems engineer explained the implications. If there's internal illumination, something is generating energy inside that object. Natural processes like radioactive decay could produce heat, but visible light requires either combustion, electrical systems, or bioluminescence. None of those should exist in a dead space rock. NASA's decision not to comment on these specific features is strategic. Discussing them would require either confirming they see the same things, which raises uncomfortable questions about what ATLAS is, or denying that features exist which are clearly visible in the images they released. Silence avoids both problems, but creates suspicion that they're withholding analysis. Curiosity's image doesn't just provide better detail, it fundamentally changes the conversation about what Atlas is and what it's doing in our solar system. The evidence visible from the Martian surface is much harder to dismiss than ambiguous telescopic observations from Earth. Before this image, scientists could plausibly argue that ATLAS's unusual properties, its trajectory, its composition, its electromagnetic emissions, might result from exotic but natural astrophysical processes we don't fully understand. Weird space chemistry, unusual orbital dynamics. Strange but possible. But geometric patterns, rectangular openings, bilateral symmetry, those aren't exotic astrophysics. Those are engineering. And that shifts the debate from, is ATLAS unusual, to who built it and why. A Harvard astrophysicist who has been analyzing the image described the paradigm shift. We've crossed a threshold here. When you see patterns and features that match spacecraft design principles, you can't keep calling it a comet. This is technology. The question is no longer if it's artificial. The question is what civilization built it and what they want. The proximity to Mars when this image was captured also takes on new significance. If Atlas is indeed artificial, its close approach to Mars wasn't random navigation. It was deliberate reconnaissance. The object positioned itself at optimal distance to survey Mars while allowing detailed observation of its own features from the Martian surface. Think about the implications. ATLAS might have deliberately allowed itself to be photographed. It got close enough to Mars that surface-based cameras could capture clear images, but not so close that it would appear threatening. It's as if someone wanted us to get a good look and start asking questions. A military strategic analyst offered a disturbing interpretation. If ATLAS is a probe or vessel from another civilization, and if it deliberately positioned itself for optimal photography, we might be watching a first contact protocol. They're showing themselves, letting us see enough detail to know they're artificial, and waiting to see how we respond. This could be a test of our readiness for contact. The timing also matters. Atlas revealed itself most clearly at Mars, a planet where we have multiple rovers and orbiters, but no human presence. If the goal was to provide evidence of artificial origin without causing immediate panic, revealing yourself at Mars rather than Earth makes sense. It's close enough to be studied, but far enough to avoid seeming immediately threatening. Within hours of the images released to the scientific community, debates erupted across multiple fields: astronomy, engineering, astrobiology, even philosophy and theology. And the division find reassuring. If we confirm that ATLAS is artificial, it doesn't diminish humanity's significance. It expands our understanding of God's creation. We've always believed the universe was vast and full of wonders. Now we might have proof. But not everyone is sanguine. Some view the evidence of superior technology as potentially threatening. Military analysts worry about capabilities. Security agencies worry about intentions, and some philosophers worry about the psychological impact on human civilization of discovering we're not alone and possibly not the most advanced. The public reaction has been mixed. Some people are thrilled at the possibility of confirmed extraterrestrial intelligence. Others are skeptical, demanding more proof before accepting such an extraordinary claim. And some are frightened by implications they don't fully understand but instinctively fear. Social media is flooded with theories ranging from scientific speculation to wild conspiracy. Some claim ATLAS is proof of ancient alien visits to Earth. Others believe it's a warning about cosmic threats. A few even suggest it's a human-made spacecraft from the future, sent back to study our present. The signal-to-noise ratio in public discourse is approaching zero. Curiosity's image doesn't answer the biggest questions about ATLAS, it makes them more urgent. We now have the clearest photograph ever taken of this mysterious object, and what it shows is geometry, patterns, and features that look disturbingly artificial. But clarity brings new problems. If Atlas is artificial, we must confront questions humanity has debated for centuries. Are we alone? Has another intelligence achieved interstellar travel? What do they want from us or our solar system? And most importantly, are we ready for the answers? The thing nobody tells you is that this image might be a gift. Atlas positioned itself at exactly the right distance and angle for Curiosity to capture these details. It's almost as if whoever or whatever controls Atlas wanted us to see clearly, wanted us to start asking these questions, wanted us to begin preparing for what comes next. A NASA scientist who spoke anonymously offered this perspective. We're past the point of denying something extraordinary is happening. The question now is whether we have the wisdom to respond appropriately. Fear and hostility are easy responses. Curiosity and careful diplomacy are harder, but might be what this situation requires. Atlas is still out there, still moving through our solar system, still broadcasting its mysterious signals. And now we have an image that makes it harder to pretend it's just a space rock. The geometric patterns don't lie. The structural features don't lie. The bilateral symmetry doesn't lie. We're looking at something that was designed, built, and sent on a journey across the stars. And it's here, in our solar system, possibly watching us as carefully as we're watching it. The clearest image we've ever seen of ATLAS raises more questions than it answers. But perhaps that's the point. Perhaps the entire encounter is designed to make us question our assumptions, challenge our understanding, and prepare for a universe far more complex and populated than we imagined. Curiosity sent us the clearest image. Now we must find the clarity to understand what it means and the courage to face what comes next. What do you see in that image? Engineering or coincidence? First contact or false alarm? The debate is just beginning, and the answer might determine humanity's future in a universe where we're no longer alone.